Hello friends, welcome to our channel Knowledge Amplifier, and today in this particular video I am going to discuss one very important concept related to machine learning and data science, and this is related to the classification component of machine learning. Okay, so what is that? We have already seen the accuracy concept to get the idea about how well my model which we have trained is working, right? We have seen confusion chart or confusion matrix as well. Now let me discuss one particular disadvantage of accuracy score. Okay, so first here I am taking one box. I am creating one simple confusion chart for binary classification. Okay, right, so here what I can do, here I can create one like this, and here also I can create one like this, right? Or maybe here itself I can create like this. Okay, and here one like this, and here one smaller one I can do like this, right? And here let me just make one in MS Paint. I am showing. Okay, so it looks good. So this is our actual. Okay, let me write the complete one. Handwriting is bad, sorry for that, because I am writing using mouse pointer. Okay, actual, and this one is predicted one. Okay, okay, right. Now this is binary classification. So what are the possible outcomes for actual? Either that one particular row is belonging to class 0 or class 1. Okay, similarly for prediction, what might happen, that the predicted outcome either 0 or 1. So actual 0, if actual is 0, predicted by our machine learning model can be 0 or 1. If actual level is 1, our prediction outcome can be 0 or 1, right? Now see what I am writing and observe the writing pattern. Okay, actual 0, predicted is also 0. Okay, that is our prediction is correct, right? So here we will be writing true. Okay, actual is 0 in this row, but see prediction is 1. Okay, that means this is false. Okay, our prediction is going wrong. Here in this row actual is 1, now prediction 0. Okay, prediction 0, actual is 1, that means no doubt this is false, right? And here, okay, let me just turn on the battery. And here our actual level for this particular record is 1, and we can see the predicted one is also 1. Okay, right? So what we have to put here, we have to put true here, because this is correct prediction, right? So this is the simple true false we have written. Now you see what I am writing next. So there are two possible outcomes of our prediction, 0 and 1. Now 0 is lesser than 1, so you can consider this as negative, and 1, this is one positive value, so consider this as positive. Okay, simple words, simple to remember. Now see, just map 0 or 1 based on our prediction. Okay, so prediction is happening here in this particular first column is 0. Okay, which is basically negative. So here I am writing n, here I am writing n. For this second column, the prediction outcome is 1. Okay, which is positive. This is p and this is p. Okay, so this is one kind of nomenclature I can say, or format to denote the elements of our confusion chart or confusion matrix. This is called TN, true negative. Okay, because I have told you that 0 stands for n, that is negative, and here our T is true. Okay, this is FP, false positive, this is FN, false negative, and this is TP, true positive. Okay, so see only this side whatever values we will be getting, and in this side whatever values we will be getting, that is correct prediction. Because in this particular box, when actual outcome is 0, prediction is also 0, and when in this particular box, when actual is 1, prediction is 1. So this diagonal, these two elements are correct and these two are false. Okay, right? Now how we compute accuracy? These two combination, that is correct prediction, so it will be basically my total negative, sorry, true negative plus true positive divided by all total. Okay, true negative plus false positive plus false negative plus true positive. Okay, this is our actually formula for accuracy, right? Life was good until and unless we got any imbalanced data. Okay, because in imbalanced data, what happens, this accuracy never gives us good idea about the working of the machine learning model. Because you just see, suppose I am having 100 data points, and out of that 99 data points, okay, are belonging to one particular class and one data is belonging to other class. That time what will happen? Suppose, consider you have trained one machine learning model, and that machine learning model is actually predicting every input as this class. Okay, that means only one misclassification will occur for this one. So actually the accuracy for that model will be 99 correct prediction and divided by total number of data points, which is 100. 0.99 is accuracy. You just think how much high. Okay, but this is not good, because here this imbalanced data is actually affecting in this high accuracy. So it is not like that always that very good accuracy is actually indicating your model is very good. Because you can see here imbalanced data, in imbalanced data, suppose you have trained your machine learning model in worst possible way, following all the bad practices, then also if your machine learning model just follows the majority class outcome, then it can score easily 0.99. Right? We can never say that that is going to be a good machine learning model. Okay, that model will be good one which can handle this kind of imbalance. That is, for this one also it can find out the pattern and it can conclude something, some other class based on this. Okay, so that's why scientists came up with some different formulas which are very important in some particular business use case or in some particular context. Okay, right? See, I am writing here one parameter, one formula. Just try to understand what this is indicating. So first thing, we have seen that accuracy is not always the good measurement, and that's why many different formula came up from this particular chart. Let me write one of them. Okay, so true positive, this is indicating what? Our prediction outcome is 1 and actual level is also 1. Okay, perfect. Now what is this particular one? False negative. This false negative is our prediction outcome is 0 but actual level is 1. Okay, right? Now see, consider one particular situation where this false negative is a very important factor. Okay, you can consider the situation like this. Suppose, can a particular person is suffering from cancer or not? That has to be detected. Okay, now you have to train one machine learning model which can do this work for simplification purpose, right? Now you see, the person is actually cancer patient. Okay, that is, the person's true level is 1, but the machine learning model is predicting that as 0. That is, the machine learning model is trying to convey this message that the person is not suffering from the disease cancer. And you just think, what is the outcome of this? If the person comes to know that he is not suffering from cancer, he will not go ahead with proper treatment, and at the end of the day he might go to such stage where after that doctors cannot survive that patient and eventually he may die, right? So this, in this particular healthcare context, this false negative is a very important factor. Okay, that is, if the person is actually suffering from any disease and our machine learning outcome is telling that no, the person don't have that disease, that time what will happen, that very big mistake might occur. Okay, that time this false negative we should take care of. In the model training part, we should focus this on this. That's why this particular parameter came, TP by TP plus Fn, true positive by true positive plus false negative. What this is indicating? See, ultimately this true positive is the main factor, actual one, predicted one. Okay, that is, person is suffering from cancer, and our prediction is also telling that yes, the person is suffering from cancer, right? True positive, always in the numerator, the major priority we should keep on true positive part. Okay, right? Now try to understand here, this particular formula is written such that it will give more importance in this Fn part. Okay, so suppose you just consider this healthcare condition which just now I explained. Here, if false negative goes high, then this particular whole term will go down, right? And as a result, eventually what will happen, that the machine learning engineers, the data science engineers have to focus on the model to increase this particular factor. Okay, this is called recall. No need to remember the name if you are getting confusion, but I hope you have got the feeling. Here this particular formula is giving more importance on this false negative part. Okay, right? I hope you have got the feeling. One more interesting component formula I want to show you, that is TP by TP plus FP. What this is indicating? Try to understand. This particular formula is giving more importance in this false positive case. There are some situations where we need to handle this particular cell very carefully. Okay, why? Who, in which situation? Let me discuss. So what false positive is indicating? That is, actually label is 0 but prediction outcome is 1, and this will impact a lot in the spam classifier, in the email. What we observe in Google email, Gmail, everywhere this is followed, right? If you just see, the spam mails are automatically classified and put in a separate part, right? Now consider one particular mail which is actually 0, that means that is not a spam mail, right? But the machine learning model is predicting that as 1, that is, machine learning model is predicting that as a spam mail, right? That time what will happen? This will be a blunder mistake, and the actual original important mail may go to spam box, and we might not check, and we might miss very important work. Okay, so that time this false positive plays a very important role. So if you just go through this formula, that is, again, you just map this in this particular context. Obviously, first target will be this true positive should be done properly. That is, our actually that is spam mail, and prediction is also spam mail. Okay, mode it, but good it. Okay, divided by TP plus FP. Now suppose in this particular context, FP, that is actually the mail is not spam mail, but our prediction outcome it is telling it is spam mail. That time the false positive will increase. Okay, if more this kind of thing happens. So if false positive increases, this particular whole term will basically reduce. Okay, and then the data scientist or machine learning engineers should take care of the model training part and try to improve this particular factor. Okay, right? So depending on different context, the formula, different formula, the data scientist has to check and optimize those. Not only the accuracy, but this depends on business use case. I hope you can understand easily. This particular factor is called precision. Okay, I am writing in small format. It's precision. Okay, now how to remember? Very simple. Precision starts with P, so here only play of P is there. P, TP by TP plus FP, and recall one is TP by TP plus Fn. TP is there. Okay, TP by TP plus Fn means recall. TP by TP plus FP is basically our precision. P, precision P is there, so in the formula of precision P is there. In recall, P is not there, so here we are using Fn. That's it. Okay. So I hope you have understood that in which context, which particular basically performance measurement formula you need to focus to understand how well your model is. That's what I wanted to discuss. I hope you have understood this, enjoyed this, got the feeling that why accuracy is not only the best way to test the accuracy or how good our model is, right? So depending on business use case, first try to think which particular parameter you should play with, and then go ahead with training your machine learning model and improve that particular factor. Okay. So this is all for this video. If you find this video helpful, then please like, share and comment. Subscribe my channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of my latest videos. Thank you.